So let's use those square roots to solve some quadratic equations. So the first thing we need to take note of in all these examples is there's no x term in our equation. So the first one, x squared minus 49. There's no, if we go to our y equals ax squared plus bx plus c, there's no bx term. It's missing. There's an x squared, there's an integer piece, there's no x term. Same thing on the second and third ones. So that's what allows us to use square roots to solve. And so our approach then is going to be a little different. Unlike factoring, where we set it equal to 0 and then break it up into two sets of parentheses, here we're going to isolate the x squared. I'm going to get that by itself on one side of the equation. So in this case, that means I'm going to have to add 49 to both sides. So I've got x squared equals 49. Now I'm going to take the square root of both sides, because that will cancel out the square above the x. So the square root of x squared leaves me with just x. And then on the other side, I can take the square root of 49, which is 7. But whenever we take the square root of both sides of an equation, this is very important, we have to include a plus or minus in front of one of the two sides. We actually could include it in both, but that would be overkill. So instead, I'm going to leave the x as it is, and I'm just going to put the plus or minus in front of the 7. And so what this means is we have two answers, as we usually expect from these quadratic equations. Since the highest exponent is 2, we have positive 7 and we have negative 7 as an answer. So I've mentioned before, we can either write our answer in this plus or minus format, or we could list them off individually, negative 7 and positive 7. Either one of those will do. For the second one, we'll do the same thing. I can go ahead and subtract 63 from both sides. So I'm going to have negative 7x squared equals negative 63. I'm then going to divide both sides by negative 7, so I'm not going to take the square root just yet. I need to get that x squared totally isolated. So if we do that, we get x squared equals negative divided by a negative is positive, 63 divided by 7 is 9. So now we can take the square root of both sides, and so we get x equals square root of 9 is 3, and then once again we have to include that plus or minus in front of one side or the other. So we'll leave the x as is, and then we'll throw that plus or minus in front of the 3, so we've got our two answers. For the last one, same idea. I'm going to add 36 to both sides, so I've got 25x squared equals 36. I'm going to divide both sides by 25. I don't want to take the square root of both sides until I've totally isolated the x squared. So that's what we've done here. Now on this side over here, I'm going to leave it as 36 over 25. I'm not going to convert it into a decimal or anything like that, because now when I go to take the square root, I'm going to take the square root of that entire fraction, and hopefully we recognize that we have a square root in both the top and the bottom. And so when it comes to taking the square root of a fraction, we just take the square root of the top number and the bottom number separately. So we can think of it as the square root of 36 divided by the square root of 25. And so in that case, we're going to get, don't forget our plus or minus again, since we took the square root of both sides. Square root of 36 is 6, square root of 25 is 5. So we really don't want or need a decimal answer. I think we're better off if we just leave it in fraction form, take the square root of that fraction, and then simplify from there if we can. In these next two examples, we're not going to end up with a perfect square when we isolate the x squared, but that doesn't change our process. It just means that we're going to have to use some of our simplifying techniques from the beginning of these notes. So I'm going to add 80 to both sides. Again, my mission is to isolate the x squared. So now I have 2x squared equals 80. I'm going to divide both sides by 2. So we get x squared equals 40. So now I'm going to take the square root of both sides. So I get x equals, and now I have plus or minus square root of 40. Still need that plus or minus, but now I need to try to simplify that square root of 40. So there's any of a number of ways that we could simplify or factor tree 40, but I'm going to opt for 4 times 10 because that's going to get me directly to a perfect square. 4 is a perfect square. I can take the square root of that. 10 factor trees into 5 and 2, but that doesn't lead anywhere, so I'm just going to leave it. So I get x equals plus or minus, so the square root of 4 is 2, so I'm going to have a 2 on the outside with the root 10 on the inside. For the last one, I've got 26 that needs to be added to both sides. So I've got 4x squared equals 26. I'm then going to take this 4 and divide it on both sides. So I get x squared equals, now again, that doesn't divide in evenly, but we don't want to go to our calculator and punch in decimals. If there's no decimals in the original question, we don't want decimals in our final answer. We're going to leave it in fraction form. But I can reduce this fraction. I can divide the top and bottom by 2. So I get 13 over 2. So now I'm going to have to take the square root of both sides. So I get x equals, now I'm going to split it up into separate square roots of square root of 13 on the top and square root of 2 on the bottom. And I do still need my plus or minus out front. And so here we have a square root in the denominator. We talked about this at the beginning of these notes, that we can't have a square root in the denominator of a final answer. So our technique for that is going to be to multiply the top and bottom by root 2. So that means I still have my plus or minus. On the bottom, root 2 times root 2, the square roots cancel out, so I just have 2. So I've eliminated the square root from the denominator. And then up top here, I'm just going to multiply these two numbers. They're still underneath the square root symbol. The square root symbol doesn't cancel out in this case because I'm not multiplying it by itself. So just 2 times 13 is 26. So we've got the square root of 26 divided by 2. So we've got our result here.